absolute value inequalities. Before we get into the inequality part, let's remember what absolute value represents. So we look here at the beginning and we see the absolute value of x equals 2. We just need to remember that absolute value just represents the distance between x and 0, right? Or between the distance from 0 on a number line. So now if we take that to an inequality, so on our second example, we see absolute value of x is less than 2. So what that tells us is that the distance between x and 0 is less than 2. So that brings us to this number line right here. And if you'll notice, or if you remember from the compound inequalities video, we have and compound inequalities and we have or compound inequalities. This right here looks like an and compound inequality because we have two endpoints in the shading in the middle. All right, so we're going to make a connection between less than and here in just a minute. And now we look at absolute value of x is greater than 2. So in this case, that means that the distance between x and 0 has to be greater than 2. So that could be a lot more possibilities, and that's going to look like this number line right here, which would represent an or inequality. We have two endpoints and we have arrays going in the opposite direction, okay? Now remember, less than or greater than, we have open circles. These same rules could apply if we have less than or equal to. We would just shade in the circles, okay? So let's make that connection. I have an acronym that you can remember, and it's called LAGO. LAGO stands for less than and greater than or. So that tells me if I'm looking at my absolute value inequality and I see a less than symbol, it's going to be an and compound inequality, and I'll just solve it as such. If I look and see a greater than symbol or greater than or equal to, then it's going to be an or inequality, and we'll solve it as such. So we'll look at one of each of those examples here today. Number one, we have the absolute value of 2x minus 1 is less than 0. So we see that less than, and we need to think and, right? Less than and. So we can go ahead and set up our two compound inequalities. And what we're going to do, the first compound inequality, we are going to write just as it is written. Okay, so we're going to say 2x minus 1 is less than 11. So is that exactly as it's written? We're just dropping the absolute value bars. We'll solve it in just a second. The second compound inequality that we're going to write, what's inside the absolute value stays the same, 2x minus 1. But we need to flip the sign, and we need to make the right side opposite. So instead of positive 11, we have negative 11. So this means our solutions are going to be less than 11, but greater than negative 11. So we're going to see what that's going to look like on our number line in just a second. So now we need to solve this to get it solved for x. So we're going to add 1. So we get 2x is less than 12. Divide both sides by 2. X is less than 6. And over here we add 1. So we get 2x is greater than negative 10. Divide both sides by 2. And we get x is greater than negative 5. So remember, with an and compound inequality, we can write that together as one inequality with our variable in the middle. So we put negative 5, our smaller number on the left, our larger number on the right. So we're looking at this right here. This tells me x is less than 6. So I put less than right there. This one is x is greater than negative 5. But what we're doing when we're writing it together is we're like reversing that, right? So instead of saying x is greater than negative 5, we could say negative 5 is less than x. And we've written that as a compound inequality altogether. So this tells me our solutions are between negative 5, so open circle on negative 5, and 6. So greater than negative 5, but less than 6. Okay, greater than negative 5 and less than 6. And number 2, we have 3 times the absolute value of x plus 1 minus 7 is greater than or equal to negative 1. So this greater than or equal, we're going to think greater than or, right? Less than and greater than or, okay? We have two things happening to our absolute value that we need to undo. So let's add 7 to both sides. 3 times the absolute value of x plus 1 is greater than or equal to 6. And we'll divide both sides by 3. So we get the absolute value of x plus 1 is greater than or equal to 2. So now we can write our two related absolute value inequalities. And let's do x plus 1 is greater than or equal to 2. That's exactly as it's written. Or x plus 1, flip the sign, less than or equal, and make it opposite, so negative 2. So we just subtract 1 from both sides. So we get x is greater than or equal to 1. Or we subtract 1, x is less than or equal to negative 3. and we'll just keep those separate since it is an or inequality. And now we can graph those on our number line. So x is less than or equal to -3. So -3 with a closed circle, and we shade to the left. And greater than or equal to 1. So 1 with a closed circle, and we shade to the right. And that's how we solve absolute value inequalities.